the first example of hypothesis testing. We want to test here about the miles per gallon. The question is, does the given data support the claim that MPG of cars manufactured by the 5 countries exceeds the standard of 22 miles? So here, X is MPG of cars manufactured by the 5 countries. And mu is the average MPG of all the cars manufactured by the 5 countries. It is normally easier to set up the alternative hypothesis. The condition that we want to prove should go in the alternative hypothesis. So here we want to prove whether the average MPG exceeds the 22 mile standard. So mu is greater than, we put the value 22 in a separate cell so we can use it in a formula. So that makes the null hypothesis the opposite of the alternative. Lesser equal. So next step is to calculate the t statistic, and for that we need these three numbers for MPG. I have already named the data. So n is count MPG. X bar is average of MPG. The standard deviation is STDEB dot S of MPG. Formatting. Now the standard error is S over square root of n. Standard deviation S divided by square root of. Next we calculate the t statistic. Here is the formula. So we go x bar right there minus mu sub 0. That's the value of mu in the hypothesis. We divide by the standard error which we just calculated right here. So that is the value of t. Degrees of freedom is n minus 1. Is this a one-tailed test or a two-tailed? It is a one-tailed test, so we need to use t dot this dot rt. That is the function for one-tailed test, and we must always do absolute value of t in this function. Then degrees of freedom. That will give us the p value. Format it as a percentage if you like, couple decimal places. Since the problem doesn't state an alpha, we use 5% as the default value. So the conclusion is, since p-value 0.67 is less than 5%, then we can reject the principle. What is that? And what does that mean? We need to give an interpretation. This, we have sufficient sample evidence to conclude that the average MPG of cars manufactured in the 5 countries exceeds the Ch02 HT standard. Remember, we are making this conclusion based on samples, so there is a chance of type 1 error. So the probability that this conclusion is wrong, so there is type 1 error, is that probability is the p-value which we just computed, 0.67%. So the interpretation has 2 parts. One part is to describe the conclusion. The second part is about the probability of type 1. Now justify the interpretation into the thought.